Now, I just finished now. I told you that there are many compounds which have got less than 8 electrons in the outermost shell, like AlCl3, BF3, BCl3, etc., which are quite stable. Similarly, there are compounds which have got more than 8 electrons in the outermost shell, like SF6, IF7, PCl5, which are also stable. There are also compounds which have got 8 electrons in the outermost shell, they are also stable. There are also odd electron pairs, got it? They are also stable. How it is? So now we are going to explain it. First we will come to those particular compounds which have got less than 8 electrons in the outermost shell, like BF3, AlCl3, BCl3, BeCl2. How it is stable? Now, one person was there, his name was Sigwick, Sidgwick. Sigwick's theory of maximum covalency. Sigwick's theory of maximum covalency. Now, Sigwick suggested that it is not necessary that all the elements in the periodic table should obey the octet rule. It is not necessary. According to him, listen carefully, according to him, he said that is, hydrogen should have 1 electron in the first period. In the second period, the maximum number of electrons in the outermost shell can be 4, not 8. Similarly, for the third and fourth period, the maximum number of electrons should be 6. And fourth period onwards, it should have the octet structure. Again I repeat, according to Sigwick, as we say that either it should obey the octet or the triplet, then only it will be stable. Just now I said it is having less than 8 electrons, how it is stable? Got it? You might be thinking. So Sigwick said that it is not necessary that all the elements in the periodic table should obey the octet structure. It is not necessary, not at all. Like for the first period, hydrogen, let us say, should have 1 electron. If it is having 1 electron in the outermost shell, stable. No need to see whether it is octet, duplet or what. Similarly, for the second period, if it is having 4 electrons in the outermost shell, then it is said to be stable. Got it? If it is 4, then it is said to be stable. Similarly, third and fourth period should have 6 electrons in the outermost shell, not 8, 6. If it is 6, stable. Fourth period onwards, we will see octet rule. So, octet rule comes from fourth period onwards. This was the theory given by Sigwick. Now, how far this theory is true, whether it is true for all the compounds or not sure. Alright, it is not sure. Only for some of the compounds you can try it out and see it is being true. So, in this way, whatever it is, Sigwick's theory of maximum covalency goes in this particular manner. At least it tried to solve the problem that why the elements are stable, why these compounds are stable even if it does not obey the octet structure, even if it has got less than 8 electrons in the outermost shell. If it is not true for all, but it is true for some, that is, we can say that. Next comes the next theory, it comes here, Suggen's view of singlet. This is singlet linkage. Suggen's view of singlet linkage, we can say that. Now, Suggen's, what he said is that, alright, in some book you will find it is written SUGD, in some it is SUDG. Alright, it is nothing but a Russian name, so hence the spelling differs in this particular way. Like Mendeleev. In some book you will find F, in some book you will find V. Alright, so it depends. So that is nothing to worry about it. Now, Suggen's view of singlet linkage. Now, this particular theory, it is put forward for those compounds which have got more than 8 electrons in the outermost shell. More than 8 electrons. So, like PCl5, SF6, IF7 in this way. Alright, for those compounds we can say that. Clear? Now, that is what Suggen has to say. Suggen says that after obtaining, that is, suppose a compound is there, it is sharing electrons. Once it attains the octet structure, alright, once it attains the octet structure by sharing of electrons, once it attains the octet structure, then the remaining, what you can say, the electrons which is being there between the two elements, it will form not a full bond, it will form a half bond, which is called a singlet linkage. I will explain it with an example, just listen. Suggen says that after it obtains the octet structure, let us say sulfur is having 6 electrons, it requires 2 more. So 2 more electrons it gets from 2 fluorine. So it is fine. Remaining, what you can say for fluorine, sulfur, what it will do? Sulfur, it will not share completely. That is, the sharing is going to take place, but not completely. What is that? That is, a half bond will be formed. That is, a singlet linkage is being formed. Alright, so hence it is being said that Sargent's view of singlet linkage. Now let me explain you with the help of a example, then you will come to know that what is this singlet linkage or half bond. Now see here properly. See here, I am giving the example of SF6, sulfur hexafluoride. Alright, by this Sargent says that none of the compound disobeys the octet structure. Every compound obeys the octet structure. None of the compound disobeys the octet structure. See here, sulfur, I am taking it here. Now this is circle, I am doing it. The sulfur is having how many electrons outermost shell? 6. I am making 6 cross. Okay, you can make dot also, it's up to you. 1, 2, 3, 4, 5. Let me take the 5 here and 6 here. Now what you do is that this is for one fluorine, this is for the second fluorine, this is for the third fluorine, this is for the fourth one, this is for the fifth one, this is for the sixth one. 1, 2, 3, 4, 5 and 6. We can start. Okay, now fluorine is having how many electrons in the outermost shell? 7. 1, 2, 3, 4, 5, 6 and this is 7. See here, now count it. Sulfur was having 6 cross, one more dot is added. So sulfur has got how many? 7. Fluorine has got 7 dot, 1, 2, 3, 4, 5, 6, 7 and 1 cross. So it is how many? 8. So sulfur is 7 and fluorine is 8. This fluorine is stable. Correct? Now coming to this fluorine. 1, 2, 3, 4, 5, 6 and here it is 7. See here, 7. So in this way, this fluorine is also stable, 7 plus 1 cross stable, and sulfur is now stable. Sulfur is now stable. Alright, see here, sulfur was having 6 cross, 1, 2, 3, 4, 5, 6 and 2 dots, 6 plus 2, 8. Done? So it is a full bond. Full bond means see here, sulfur, this was 1 fluorine and this was 1 fluorine. It got full bond. Clear? Now you see what happens. Now fluorine, what will happen is that 1, 2, 3, 4, 5, 6 and the 7th will be inside it. So fluorine, it does not share its electron with sulfur, but sulfur shares its electron with fluorine. Fluorine does not share. You look here, the fluorine, the electron is where? It is within fluorine atom only. I have done it. I have not done it here in other cases. See it. So fluorine is not sharing with sulfur, but sulfur is sharing this electron with fluorine. Alright, as a result, what happens is that fluorine becomes 8. 7 dots is there, 1 cross, 8. And sulfur was already 8. It does not require any more electron. So hence, how will you show this? You will show it in this way. This is half bond. Same thing for this fluorine also. 1, 2, 3, 4, 5, 6 and the 7th one is here. See carefully, the 7th one is here. So fluorine 7 and 1 cross, 8. Sulfur was already 8. Now sulfur, this dot does not come here. So the sulfur number of electrons is not increasing. See, sulfur number of electrons is remaining same. Till now it is 8 only. 6 cross and 2 dot. Till now it is 8. This dot I have not done here or I have not done here. So sulfur it is not increasing. Mind it. Sulfur remains 8 only. So another half bond you get it. Clear? Same thing for this fluorine. 1, 2, 3, 4, 5, 6 and the 7. Again same thing. Another half bond is there. You can see it. Fluorine 7 and one more cross from fluorine, that is nothing but from sulfur, it is 8. Alright, it forms half bond. Here also 1, 2, 3, 4, 5, 6 and 7. Alright, here also half bond. So ultimately, what you find? Ultimately, there is 4 half bonds and 2 full bonds. So hence sulfur it is 8 only, count it and see. 1, 2, 3, 4, 5, 6. You can zoom it and you can see it. Alright, and here it is sulfur, what you can say? 2 electrons is there. Fluorine 2 electrons is there. So 6 plus 2, 8. After that, any electron you can find? From fluorine? No. The fluorine does not share with sulfur, but sulfur shares with fluorine. In this way, sulfur remains octet only, and fluorine also attains the octet structure. So this is called as singlet linkage. This half bond is known as singlet linkage. Okay. In this way, Sargent says that none of the compound disobeys the octet structure. All the compound obeys the octet structure. Same thing with xenon fluoride. Same thing with PCl5, same thing with xenon oxyfluoride. You do it and see, you will be getting it. Alright, I hope you understood. Alright, better you do some more examples, you will understand it. Now, in this way, clear. So, you can do it and you can find it out that it does not disobey the octet rule. So, you are having full bonds, then after that we are having the remaining is your half bond. Got it? So this is called a Sutton's view of singlet linkage. By this we are able to explain, but the odd electron is there. That I will explain you later on, little bit later on. Wait. So in this way we have explained it. Got it? By the Sigwick's theory of maximum covalency and the Sutton's view of singlet linkage. The compounds which we say does not obey the octet structure, but they have given their own theory to explain this particular compound. Fine. Now we will come to the Lewis dot diagram. Lewis dot diagram. Now Lewis dot diagram is what? Just we will represent here the valence electron with dot. That is called as Lewis dot diagram. The valence electrons will represent it by dot. Okay. For example, fluorine has got 7 electrons. So 1, 2, 3, 4, 5, 6 and 7. This is 7 dots. This is a dot diagram for fluorine atom. Alright. Now for oxygen 1, 2, 3, 4, 5, 6. Oxygen. Alright. For hydrogen 1 dot. Clear? In this way, every element we can represent it the valence electron by dot. This is called Lewis dot diagram for elements. Now, next is we'll come to the Lewis dot diagram for compound. How to draw it for compound? For example, water. For example, like charged particle, radical like carbonate ion, cyanide ion. For example, acid like sulfuric acid, nitrous acid, phosphoric acid, like ammonium radical. How do you draw it? Alright, here also you can draw the odd electron and I can show it to you. So now we are going to draw the Lewis dot diagram for the compounds. This is for the element. It's quite simple. It's quite simple. It's very easy. Just you will show the valence electron with the help of dots. That's it. You can see 7 dots. Now children, listen carefully. Alright, listen it very carefully because things are getting tougher for you now. Alright, so hence listen it very carefully, understand it very carefully. When you see the video, when you see this particular AV, any doubt is there, you pause it, go back, again come forward and see it repeatedly. Then only you will be able to understand it. Alright? Yeah. Now, let us say I want to draw the Lewis dot diagram for carbonate ion. CO3 CO3 2 minus carbonate ion. So what are the steps I should follow to draw the Lewis dot diagram? Listen carefully and write it down. First you need to find it out. The number of valence electrons in carbon and oxygen along with these 2 electrons. 2 minus means what? 2 electrons extra. Isn't it? You need to draw. The number of what you can say valence electron in carbon and oxygen, you need to draw it, and after that you need to add it at. Alright, first you need to draw, first you need to add, then you will draw it. Alright, yeah, fine. So carbon, the first step is that add the total number of valence electron present in the given species. Add the total number of valence electrons present in the given species along with the charges. Along with the charges. Along with the charges means this one. If it is 2 minus means 2 electrons more. So plus 2, I'll add it. Suppose it have been here 2 plus, then 2 electron less, minus 2 I have done. Suppose if nothing is there, like CO2, neutral. So no need to add, only will add the valence electron. Okay, like. So total number of valence electrons, total number of valence electron in CO3 2 minus. It is how much? Carbon, it is 6, carbon atomic number is 6, it is 4 electrons is there in the outermost shell. Valence you understand or not? Outermost shell. Oxygen, it is 6, 6 into 3, 18, plus 2, 2 electron in this way. So 18 plus 2, 20, 24. So we got 24 electrons. Now the second step is find the pair. We will find the pair of valence electron, pair of electrons. So it is 12 pairs it will be, because 24 by 2 it is 12 pairs. So we got 12 pairs. So we have to arrange the 12 pairs. Where you will arrange? The third is you draw a rough diagram, which is called as a skeletal diagram. Means you just arrange it roughly. Like carbon will be there in the middle, definitely the central atom, and this oxygen here, and this oxygen here. Definitely, or you say no sir, I will put on oxygen here, here. 3 oxygen you have to put at 3 coordinates. Finish. So this is a skeletal diagram. The third step is. And the fourth step is that you need to arrange this 12 pair of electrons. That's the most important one. You need to arrange the 12 pair of electrons around carbon and oxygen without violating the octet rule. That's a very important point to remember it. You need to arrange this 12 pairs of electrons around carbon and oxygen without violating the octet rule. You need to arrange this 12 pairs. So see here carefully. Alright, now this particular thing you have to develop by doing practices. Alright, The more you practice, the more perfect you will be. Now see here, you can start from anywhere, from carbon, oxygen, anywhere. You can start from. Now suppose I start from oxygen here. 1, 2, 3, 4, 5, 6. Because oxygen has got 6 electrons, let me put it 6 and see what it happens. Now here it is. Now this 2, let me put it here. Alright? Because it will be sharing. Now same thing, this oxygen also has got 6 maximum. 1, 2, 3, 4 and 5, 6. Now this oxygen also has got 6. 1, 2, 3, 4, 5, 6. Alright. Now see what is happening. What is happening? See here. So how many pairs we got it? 1, 2, 3, 4, 5, 6, 7, 8, 9 pairs. 3 pairs more I have to arrange it. But without violating the octet structure. 3 more pairs. So the total 12 pairs are there. Na? How many pairs I got? See, 1 pair, 2 pair, 3 pair, 4, 5, 6, 7, 8, 9 pairs I got it. 3 more pairs without violating the octet rule. Here, what you find is that none of the element is stable now. None. Okay. Let me put here a pair here. Let me put a pair. So what it becomes here? 1, 2, 3, 4, 5, 6, 7, 8. This oxygen is stable. Even carbon is also stable, you see. Carbon 1, 2, 3, 4, 5, 6, 7, 8 stable. So this carbon and this oxygen is stable now. Okay. Now you need to make stable this oxygen. So here you put 1 pair and here you put 1 pair. You have to count it and you have to do it. You need to have patience. Understood? You need to have patience. Initially might be you will not be able to do, but don't lose the patience. Otherwise, what can be done? So in this way, now count it. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. See, 12 pairs I have arranged. Alright? So I started from somewhere. I started from oxygen. First I put 6 electron because maximum can be 6. By taking that, this 1 pair of electron will be with carbon. Then I saw 9 pairs is there. Then I thought that I have to arrange 3 pairs. How to do? Without violating the octet. So I put 1 pair here. By doing so, this carbon, this oxygen is balanced. Done. Now 2 more pairs. I can't put it here, this 1 pair here and 1 pair here. By doing so, what will happen? Carbon, it will increase. So hence I put it here. Done. Alright, 2 minus. Now, what is the structure here? So you can see, this 1 pair means 1 bond. 1 pair of electron means 1 bond. Here, 2 pair, 1 bond. 2 pair, 2 bonds. And this. Now you draw the unpaired. There is, these are pair, na? This is a paired electron. This is pairing with carbon. So it is paired. And this one is unpaired, we can say. Unpaired we show by the help of dots. This is only known as Lewis dot diagram. We can say that. Clear? So here this, and here also this. You can see 1, 2, 3. 3 here. Here 1 pair I have done it. Here 2 pair I have done it. And 2 more electrons here. Here 1 pair I have done it here. And here 1, 2. Alright. And this, we can say that 2 minus. This is the Lewis dot diagram of carbonate ion. In this way, we need to draw the Lewis dot diagram. Okay. Thank you very much.